All right, welcome to day 19. So your homework is page 124 to 131, 25 to 32. We're going to do 4 of them in this video, and then you'll have the leftovers to work through for the rest. A reminder that next class we will have our final review quiz. We will need compass and straight edge, as well as calculators. You can be taking that out as you're taking your homework out. So the first one from last class that we didn't do, we wanted to see which proportion was always true. So if we look at the correct choice, 2, notice we've got AB, which is hypotenuse and small, over AD, which is hypotenuse and big. So we had hypotenuse over hypotenuse. So on the right side, we would need a small triangle side over a big triangle side. So we've got BC, which is from the small triangle, matching with DE. So there's consistency there. That's why that one works. Our directed line segment. When you go from -4 to 1 for x values, that's 5 to the right. When you go from -2 to 8 for the y values, that's up 10. We had 2 parts out of 5 total parts, so we're multiplying by 2/5 for each of these. After you multiply by 2/5, remember that's not a point. That's just the movements you're going to do. So from the -4, we're going to move 2 right, so we'd be adding 2 to give us -2. From the -2, we'd be going up 4, so we add 4 to give us +2, and then that is choice 2. Remember, if you were totally stuck on one of these, you could plot them in the graph paper on the back, connect them, look at the points that they give you, and see which would split it into 2 parts to 3 parts. We want to find the area of this triangle, so make your rectangle around. The rectangle was 12 by 11, which gave us 132. We had 3 right triangles, one that had sides of 3 and 11, 1, 9, and 7, 1, 4, and 12. So find the area of those 3 triangles and subtract it off. It ended up being 132 minus 72, so we got choice 1, 60. We're spinning this about BC. So it ended up kind of looking like that. So it's a cone going upwards. AC had 5 for its length, so therefore the diameter now becomes 10, so choice 3. Our rule here is the angle is equal to 1/2 arc plus arc. The angle should always be by itself. So we have 58 is equal to 1/2 x plus 72. We can divide the 1/2 over to give us 116 and subtract the 72. To get that dB, the arc we're looking for is just 44 degrees. We want to look for QT. So x should be over x plus 5, because that's small triangle to big triangle. And that should equal 5 over 7. When you cross multiply those, we get 7.5. Now, I saw that some people did it this way. They did x over 5 equals 5 over 2. Well, notice still that x is only QT, so that would give you 12.5. So just make sure that, oh, I should say that I got 12.5 there, and then added the 5 to get the 17.5 because they wanted QR. This one, they want the arc length. So we have our angle 120 over 360. And then we have our arc, which we don't know x, over our circumference 2 pi r. When we cross multiply, notice they don't have them multiplied out. So a lot of people I saw when they did this ended up getting 4 pi, which is great. And then that rules out choice 2 because it doesn't have a pi. And then you can just multiply the non-pi parts to see which one gives you 4 pi, which that ended up being choice 4. Alrighty, we're going to start on page 24, number 25. We'll give you a moment to flip there and then read through this one. All right, if we slide 2 units right and 3 units up, any translation is a rigid motion, and rigid motions do not change the size of the sides or the angles. So we can say, since a translation is a rigid motion, the sides and angles do not change size. Therefore, triangle A prime, B prime, C prime is congruent to triangle ABC. So basically, because the angles and sides don't change sides, we could have it by side, 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 angle, side, any of them, because none of the sides or angles will have changed. Our only one that is not a rigid motion is the dilation. That creates a similar figure as opposed to a congruent figure. All right, 26, we want to do a dilation. Scale factor centered at point D. If your center is at the origin, you can just simply multiply the coordinates by your scale factor. When it's not at the origin, you need to be a little bit more careful. Let's start by finding B prime. So to get from D to B, we go up 2 and left 1. Or sorry, up 3 and left 1. To do a scale factor of 2, we just need to do those movements 2 total times. So the first time gets us to B, and then we'll go up 3 and left 1 again, and that will give us B prime. To get to A, we go down 1 and left 3. So to find A prime, we need to do that movement 2 total times from D. Doing it once brings us to A, and then go down 1 and left 3 again, and that gives us A prime. And then likewise for C, we need to see how to move to C and do that movement 2 total times. Well, we're going down 2, right 3, go down 2, right 3 again, that gives us C prime. And then with our straight edge, we can connect those. And that's our image. Now you need to make sure you have those points labeled A prime, B prime, C prime, or you would lose credit. Now this does not pertain to this exact question, but notice when our center of dilation was not on the line, it created a line that was parallel to the original line. If the center of dilation is on the line, then it creates the exact same line. We're going to leave 27 and 28 for you to do on your own, and we're going to look at 29. We will need your compass and straight edge. If you need to borrow one, you can get one from the container. If we run out, then you'll have to share with someone nearby. So we want to construct a median. From proof, we have that a median implies midpoint. So we want our median going to side AC. So that means we need to find the midpoint of side AC. So to do that, we'll just do our perpendicular bisector construction. Make sure you are open over halfway. Swoop it up, swoop it down. and then we'll reverse it. Go to C, we'll swoop it up, swoop it down. And we'll connect our intersections, and really all we care about is where we hit AC. So that point there is the one we care about. So to finish this off with our straight edge, we need to connect from point B over to that midpoint that we just constructed, and that is our median. Now, it doesn't come into play in this question, but remember the medians, when they all cross, that's called the centroid. And we saw the other day the key feature of the centroid is it divides the median in a 1:2 ratio. That sometimes comes up in questions. All right, let's go to number 30. We'll give you a minute to read through it. All right, well, let's check and see if we can get these to be congruent. Notice they're right triangles. So let's maybe see if we can find this missing side by Pythagorean theorem. So we could do 5 squared plus x squared equals 13 squared. That would give us 25 plus x squared equals 169. We could subtract the 25 over. That gives us x squared equals 144. And when we take the square root, we get x equals 12. So this side is really 12. So notice between the two triangles, we have side angle side, the right angle, and then the 5 and the 12 sides. So that's going to mean that the triangles are congruent. But if triangles are congruent, they are automatically similar. So we've got to explain that now. So we can say both are correct. We can say the triangles are congruent by side, angle, side. Since they are congruent, they are also similar by angle-angle similarity postulate. Now you may be saying, where do we get the second angle from? Well, keep in mind, once you know two things are congruent, you have congruent triangles implies congruent corresponding parts, so that could get any other pairs of angles that you needed. All right, we're going to leave 31 and 32 for you to do on your own. So in your remaining time in the period, you have 32, 31, 28, 27 to do. And then any remaining time, you can look over your gold packet to help study for tomorrow's quiz. Have a great rest of your day.